Good morning, friends. Today, I want to solve certain questions from last year's test paper of 10th class Cbse Mathematics Standard subject. So, let us open last year's test paper of code 30/S/3. I have solved up to question number 23 in my latest class. Okay? In my last class. Today, I want to attempt this question number 24. In the given figure, TQ and TR are tangents to the circle with center O. Prove that angle QTR is equal to twice angle OQR. Right? Yeah, I want to magnify this. Yeah. Now, yeah. Right. So we are given a circle and a point capital T outside that circle. We know that from the sectional point, we can draw two tangents to this circle. Say they are TQ and TR, means points Q and R are points of contact. And OQ is radius. O is center of this circle and Q is point of contact. Therefore, OQ is radius. We are asked to show that if this angle is theta, this angle is 2 theta. Means we have to show that the angle between these two tangents, that is angle QTR, this angle, is twice angle this one, that is angle OQR, right? Means this is the angle between radius and chord, okay? And this is the angle between tangents. We have to show that this angle is twice this angle. So what we do is we'll join O with R with a line segment. We get the radius of the circle, okay? And the radius arm, right? Now in this triangle OQR, this OR and OQ are equal to radius. Therefore, it becomes the triangle becomes isosceles. And equal sides subtend equal angles on the third side. Therefore, angle Q and angle R here, that is angle ORQ, become equal. Now, say it is theta. Now, we know that the angle between tangent and radius is 90 degrees. Okay? And 90 degrees. Therefore, angle TQR becomes 90 minus theta because this is theta. Right? Similarly, the angle between this radius and this tangent is also 90 degrees. Here, the angle ORQ becomes theta. Therefore, angle QRT also becomes 90 minus theta. So, this angle is 90 minus theta. This angle is 90 minus theta. So, if you add these two angles, you get 180 minus 2 theta. And the third one becomes the difference of 180 degrees and the sum of these two, that is 180 minus 2 theta, which is 2 theta. That's how this angle, that is the angle between these two tangents, becomes twice the angle, this angle, that is the angle between radius and this chord. Okay, so let us look at the working. Yeah, so this is question number 24. Right? We are given a circle and a point capital T outside this circle. We know that from an external point to a given circle, we can draw two tangents. So TQ is one tangent and TR is another tangent. Means points Q and R are points of contact of these tangents. Means they are points on the circle. Now, O and Q is joined with a line segment. O is center of the circle. Therefore, OQ becomes a radius. Now, let us join O and R also with a line segment. Yeah. So, I have joined O and R with a line segment. Therefore, this also becomes the radius of the circle. This also becomes the radius of the circle. All right? If this is small r, OQ is also small r. I'm assuming small r is the radius of this circle. Therefore, OQ becomes equal to R, means these two sides are equal. Now, if we take the triangle OQR, it becomes isosceles because these two sides are equal. And there's certain equal angles on the third side. If I assume this angle is theta, if I assume angle OQR is theta, this angle also becomes theta. Why? Because these two sides are equal. There's certain equal angles on the third side. Therefore, this angle equal to this angle. Now, TQ is tangent and OR is radius at the corresponding point of contact Q. Therefore, the angle between this radius and this tangent becomes 90 degrees. Okay? That is angle OQT becomes 90 degrees. Therefore, this angle, that is angle RQT becomes 90 minus theta. Right? This angle from here to here, from this arm to this arm, it is 90 degrees. From this arm to this chord arm, it becomes theta. Therefore, from chord to this tangent, the angle becomes 90 minus theta. Similarly, this radius is perpendicular to this tangent. Okay, because R is point of contact. Now, and angle ORQ is theta. Therefore, this angle becomes 90 minus theta. Right? The angle between this chord and this tangent is the angle between radius and tangent, that is angle ORT, which is 90 degrees, minus the angle between radius and this chord, that is theta, that is 90 minus theta. Therefore, this angle from this chord to this tangent, this angle is 90 minus theta. If you add these two, 90 minus theta, their sum is 180 minus 2 theta. And if you subtract that sum, you get 2 theta as a third angle. Means the angle between these two tangents is becoming 2 theta, where theta is the angle between this radius and this chord, means this angle. Means angle QTR is equal to twice angle OQR. Okay, so let us write the working. Yeah, right. Let or rather consider a circle with center O and radius small r. Okay. Let T be an external point and T comma Q comma and TQ and TR be TQ and TR be tangents to the circle from T with Q comma being Q comma R as points of contact, Okay, so yeah, so now join Q comma R with chord Q. Okay, and radius O Q. OQ. OQ. Okay, join O comma R with a line segment. Therefore, OQ is equal to OR So capital R is equal to small r, right? Now, what can we say? Now, 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 triangle, O, OQR, OQR is isosceles. Therefore, equal sides, O cube, comma OR, subtend, equal angles, equal angles, equal angles. Angle Q equal to angle R. On the third card QR. Okay? This is equal to theta. Say, let us assume that this equal value is theta. Uh, we have tangent. We have tangent. QT is QT is perpendicular to radius OQ. Okay? Right. Yeah. So, radius OQ. Can I grab this? I want to move this. Yeah, right. Radius OQ is perpendicular to tangent QT. Okay. Therefore, angle RQT is equal to angle OQT minus angle OQR. This is 90 degrees. Angle OQT. OQT, there's the angle between radius and tangent. It is 90 degrees minus angle OQR. I'm assuming it is theta. Okay. So therefore, this angle is theta. Angle RQT, this angle is theta. Similarly, we get angle QRT. QRT is also 90 minus theta. Okay, 90 minus theta. In the triangle QRT, angle, right? Angle QTR is equal to 180 degrees minus these two angles. Okay, that is angle QRQT plus angle QRT. Okay, triangle QRT, right? I'm calculating angle T. So that is 180 minus of sum of the other two angles. That is angle R and angle T. This is angle R and this is angle. Yeah, angle T is 180 minus sum of the other two angles. This is angle T. Therefore, the other two are Q and R. So this is angle Q and this is angle R. Okay, and each of these is 90 minus theta. Therefore, this is equal to 180 minus 90 minus theta plus 90 minus theta. Okay, this is 90 minus theta plus 90 minus theta is 90 minus 2, 180 minus 2 theta, that is 2 theta. Okay, this is twice angle. What is theta? Angle theta is angle OQR. This is angle OQR. Okay, what is theta? Theta is angle OQR. Okay, that's what I have written. Theta is angle OQR. So we have shown that angle T is equal to twice angle OQR. This is the angle. This is the angle between the tangent and the chord. Okay, between the tangent and the chord, angle OQR. Right. So this completes the answer. Thank you. I'll continue in the next lesson, right? Because uh, uh, I'm afraid whether this is recorded properly or not. So let me stop here.